Well, good morning, everybody. My name is James. I am an educator here at the Aquarium of the Pacific in Long Beach. Oh gosh, what the penguins doing? That was not me, I swear. They got scared by something else. Well, we're going to be talking about some of these feathery fun friends and some of their relatives too. We're going to be exploring birds from across our planet, but we're going to be starting with the ones on the polar sides, the penguins and the puffins. So if you want to participate today during our Aquarium Online Academy class, you can. You can text us questions at 562-286-1838. My friend Sarah is taking questions over the computer, and they'll be able to help bring them in so that I can answer your questions live on the air. Kaya is controlling all the fun behind me here, not scaring penguins, but she will be helping with the video and images that we're going to be showing too. If you want to ask questions after the program is live at 10 o'clock on a Monday morning, you can do that too. The email down here, live@lbaop.org. You can email us questions and our educators will help answer your questions. Or maybe your question is a really big question and it needs more time than we can answer here. We'll be able to answer that too on our email chain line. All right, well, let's take a look at some animals that live across polar regions. Now, they're not only in the Arctic or Antarctic pole areas. Penguins and puffins can extend well beyond the polar circles, but they do share some interesting characteristics and features. What do we observe happening to our penguins? Let's practice with them. Since we don't have a live webcam of the puffin exhibit, we can practice with our penguins. Now, how is that penguin getting around? What are they doing to move? Do they use all of their arms and legs or wings and legs to do all these things? How would you describe a penguin? Besides that one playing with something in the water and maybe calling it a little derpy, what else would you do to describe a penguin? I personally think they're like little bowling pins in the water with wings and they swim. But their shape might be a little bit different depending on the kind of penguin. They have this kind of football-ish bowling pin shape. So have you ever heard of the word aerodynamics? People study that, specifically aerodynamics, and how a gas or a fluid passes over something. So when people design what a car should look like, they study the aerodynamics of how it's going to be operating in the air. Or an airplane, or a boat. They study how water and air move across the surface. Well, think about the aerodynamics of penguins. What is their shape? Is it going to help them as they swim? This kind of football bowling pin shape is actually really important for animals to swim. Do you know of any other animals in the ocean that kind of have a football-ish shape? Think of a shark. If you were to draw a standard shark, is the shark going to be a square, long rectangle, a triangle? Well, they have triangles in their body, but their whole body is kind of this oval lemon footballish shape. There they go again. And that football shape is really, really advantageous for things that swim. Think of an animal that doesn't really swim that much. Not very footballish. But these animals are definitely footballs. Now, one of the things that sometimes our guests ask us when we're out in front of our penguin exhibit is, where are all the bubbles coming from? And I've had some of our guests, not just necessarily the young ones, but adults too, ask if the penguins are passing gas, and that's what's going on in there. Not that they wouldn't, but that's not what that is. The bubbles are the air that they are collecting into their feathers. So they'll groom themselves, like Kai was talking about sea otters grooming themselves in the last class. They get air fluffed into their feathers, and it creates this protective layering so that they don't get their skin wet while they're in the water. So their feathers do get wet, but that air layer is a trap for the heat. So it's like when we wear jackets. We trap air inside between the layers. So there's air down there, and it helps keep me warm. That does the same thing for penguins. This is going to be very different compared to the puffins. So let's start moving over to looking at puffins and seeing what's the same and what's different about these birds. These are two horned puffins. We actually have this species here at the Aquarium of the Pacific. So we have 4 kinds of what we call diving birds, or the auks. The auks are a whole family of birds that include the puffins, the guillemots, and the auklets, which are just little ones. The biggest of the auk birds is actually pretty good size. So if you're comparing a puffin and a penguin, what's the same and what's different? Well, yes, they're both birds. They both have these pretty meaty, stout-looking feet. But what else can you see as a difference? Now, don't forget, you can text us questions. You can text us observations and help guide how we're going to explore penguins and puffins. Now, I notice the eyes. Now, this particular penguin that's on this side of the screen, this one's called an Adelie penguin. They have a big attitude for being a little bird. But their eyes are a little different. Now, not all penguins have these kind of eyes, but they do have different colors and sizes to their eyes. And if you look at a penguin, their eyes have to point a little bit forward. Now, puffin eyes point a little bit forward too, but maybe not to the same degree as a penguin does. And it's all about how they hunt. So anything that has to chase their food, their eyes may point more towards the front. Now, this doesn't work on fish. Fish are a little bit different. But on birds, when you look at birds, birds that hunt other animals tend to have eyes that point more towards the front so they can see their prey. Birds that have eyes that point more towards the sides, it's so they can watch out for predators. This works for a lot of other land animals too. Well, what's another big thing we notice in this picture compared to the video of all the penguins? They're not really swimming around, are they? Do puffins get in the water? Looks like they do. Thanks, Kaya. She gave you a clue, didn't she? Well, here's a cool thing. So this bird right here is the other puffin species we have. It has very fantastic hair, but it's not hair, it's feathers. This is the tufted puffin. So you have tufted puffins, horned puffins. Here's a pigeon guillemot. And then we have the little crested auklets. The auklets are one of my favorite birds because it looks like they have, very fantastic hair in the front too. But it's more just feathers that are designed to help them look attractive to a potential mate. So here, these are even more different than the horned puffin to the penguin. So what did you notice as a similarity between penguins and puffins? It was their coloring, right? Coloring is a big portion of it, but their coloring is also different. Puffin beaks are very colorful, whereas penguin beaks tend to not be as colorful. Most of the species of puffin have some kind of colorful beak, whereas most of the species of penguin have a solid dark colored beak. So here's our Magellanic penguin that we have here at the Aquarium of the Pacific. They have an all dark beak right here. And the length of their beak tells you about what they're going to eat. If you have a short mouth, you're probably going to eat little things, right? Yeah. If you have a longer beak, you might eat bigger stuff. The longer the penguin beak is, chances are the more fish or larger the kinds of fish are that they would be eating. If you have a little short beak, like even the Adelie or even the little fairy blue penguin, you tend to eat smaller fish or even large and small krill. But penguins, like our Magellanic penguin, out in the ocean, they're eating different kinds of fish, maybe some small squid, maybe some krill if they have to. But there's a lot of energy investment in trying to eat. And if you can't get enough food, but you spend all that energy, you haven't really done anything. That's like how we try to lose weight, right? We spend a lot of energy eating a little bit of food, we can lose weight. Well, penguins, that's not really their goal. I'd rather be a penguin, honestly, because of that. But look at their face. Eyes that kind of point forward, and they have all this fun stuff going on in their mouth. This helps hold on to their food, which they do need because these rascals can eat a lot during their pre-molting season. So they're going to bulk up a little bit because when they're molting, they don't really like to eat as much. So when they're bulking up, one Magellanic penguin, I think I've heard of them eating up to 12 herring. So a penguin that stands this tall is eating 12 fish this long. I don't know where they put it, honestly. There's like cavernous in there. I don't know. But they're eating a lot of food. So their capacity to eat a lot of food is very high. Well, what about the puffins? Puffins have amazing abilities to eat lots of food too. Puffins carry their food, and especially when they're carrying their food out to the nest, a puffin might carry dozens of little tiny fish in their beak. That's how cool their beaks are. Here we go. Here's a nice picture of some of that, where they can carry multiple fish in their beak. I think a record is like over 50 fish. That's impressive, to carry that many fish in your beak, swim up to the surface, fly to your nests, and then deposit the food or eat the food. So they both eat fish, but they might eat fish differently or in different ways. Their beaks are a little bit differently designed for how they have to eat. So while they have kind of the same purpose or role in their environment, they have a little bit different design of how they do that. So their adaptations, their coloration, their size, their featheriness, all helps them survive their different habitats, even though the habitats have some similarities. All right, some questions came in. So Brooklyn from Lake Matthews Elementary, do penguins swim well? They definitely are really good swimmers. Let's go back to our live webcam of the penguins when we get a sec. So Kai's going to have to switch over things a little bit because it takes a second to bring up that webcam. While we look at how penguins might be swimming, we also have a question from Claudia asking, are penguins like other birds? Yes, Claudia, they are birds, but let's think how else they might be like birds. How are they different from other birds? So penguins are great at swimming. So this helps answer Brooklyn's question. They are birds. They are really good at swimming, but they are not going to be able to fly. They only fly underwater. So remember, when they are using their wings to move, they're doing the same thing that birds up in the air would do. They're flapping. Do you see the penguins like doing something like this stuff? Like, woo, I'm swimming! No, not really like that. They're flapping as if they were flying underwater. And then their feet help them steer. Puffins swim the same way. They will flap their wings and use their feet to steer like a rudder on a boat. So here is actually the pigeon guillemot doing this, but it's the same thing for the puffins. Now, one of the things that it's hard to tell because the birds are moving pretty quickly, but one of the things I've noticed when I watch these birds swim, the penguins stick their wings all the way out, right? They're not like a little bit. Penguins are all the way out. Woo! Big flapping. Whereas the puffins are not all the way out. They kind of pull their arms in a little bit, or their wings in a little bit. Because if their wings are all the way out, they probably would tire out, because that's a lot of surface area. So think of the different sizes of people's hands. So you might compare your hand to an adult's hand around you. There's a different amount of area on your palm, right? So you might be able to scoop up so much water. They can scoop up more if their hands are bigger. So more surface area means more pushing against the water to swim. But it means you expend more energy too. I love when something startles them. They all dive at the same time. Lots of bubbles everywhere. And they can get right up next to the underwater camera. So this camera is actually in the exhibit. This is one of my favorite times of year to watch the penguins because this is their migratory season. They are in the water a lot. During the summer, they're not as much in the water. So if you want to check out good penguin underwater footage, this is the season to do it. So those pigeon guillemots and the puffins are not pushing their wings all the way out because that's too much surface area for what they need. It expends a lot of energy, which means they have to eat more food. Remember, they're not really on a diet plan. They need to maintain their weight or even gain some weight. So they'll tuck their wings in a little bit as they swim. And they're pretty fast, even though those wings are tucked in a little bit. Now, the cool thing is both of these groups of birds dive for their food. They swim down to get to their food. The puffins and the guillemots aren't going to dive like a high jump diver where they're down into the water. They're probably at the surface and dive as they're sitting, just like the penguins would be doing. And the reason we can tell that is because of the shape of their face. Who knew the shape of your face would tell somebody how good you can swim? Well, in bird world, that's how it works. If we look at other kinds of birds, let's think of this shape here. This big, kind of meaty shape, kind of like we're making, shadow puppets. Big shape. Roar. That is good for grabbing fish, but not the best for diving in the water. So if you were to go jump in the water and you wanted to make as little splash as possible, do you like splayed out all like, woo, diving in the water? Are you cannonballing in? Or what do? We kind of point our hands into this sharp shape so that when we get into the water, we create as little splash as possible. That actually puts less force on your body to do it that way. Well, guess what? Birds naturally have that ability. Not all birds, but some birds do. Like herons or the, it's white bird, I just lost its name. The egret, yes, I can name the bird's name that lives here at the aquarium, but I forgot his species type. The egret. So look at that egret's beak. It's long and slender like a penguin. Remember, penguins don't fly, so they're not like, whee, diving in the water. But an egret can. So their neck is kind of perched back like this, and their long neck, see, when they stretch their neck out, this is a heron, but very similar effect. They stretch the neck way out. They're actually very tall. This great blue heron, if it was standing next to me, would probably be about this tall. They're very tall birds, walking around like they own the place. They're kind of sassy, too. They have this long neck, but it's not just for, like, looking over things. When they dive in the water, they'll stretch their neck all the way out, and that long, pointed beak will help as they dive and pierce the surface of the water. Just like if we stick our arms out and try to dive with our arms pointed down. That shape helps them dive in the water. So they are plunging from the air into the water, whereas other birds will be floating and then dive because they see food. So there's differences in how birds are going to hunt when they hunt for food in the ocean. Now, Anthony from Grandview is asking, what animals are aerodynamic? Good question, Anthony. So all this that we were talking about with how the birds will dive in the water, that's a special kind of aerodynamics because they're changing what fluid they're in. So in aerodynamics, gases and fluids, so air and water, behave similarly, but a little different because water is very dense. Is it really easy to run in knee-deep water? Kind of doing high knees and trying to get through the beach. It's not the easiest thing. Much easier to run in air than run in water. So water is very dense compared to air. So if you're changing from diving from air to water, your body needs to be adapted to doing that. A penguin or even a puffin diving from air into water from great heights at great speeds is not going to be very successful because of the shape of the body. Now, other birds might not be very aerodynamic like an ostrich. They can run, but it's not like their body is shaped to run really quickly. They are very fast, but that's not what the body shape is helping with. For other birds, the shape of the body really helps with how fast they can fly, or even if they're gliding birds. Think of the large birds like condors. They will spend long amounts of time up in the air. Now this is a tern. I don't know what kind because their cap color and their beak color are all very similar, and I get them all mixed up. But terns are also seabirds. Long pointed beak because they will dive into the water to get to their food, but they also have these long, graceful wings to help build up speed as they fly or even glide across great distances. So lots of birds have this aerodynamic pattern to their body, or even they have much larger, thicker beaks for what they're hunting and getting. So all these patterns and shapes of birds are helpful in their aerodynamics. They just do different things. Except an ostrich. They just have big, powerful legs to run really fast. So not for the same kind of aerodynamics. Good question, Anthony. Madison asks, are those teeth in that penguin's mouth? Let's go back to the penguin mouth because that is one of my favorite pictures. They look like teeth, don't they, Madison? And in fact, they might have some similar characteristics in that they're holding on to their food. So teeth, for us, what do, Madison? They're for biting and grabbing or tearing off parts of our food. Birds don't have true teeth. They might have a serrated bill. So think of like a steak knife. Somebody pulls out a knife that we use to cut meat. It has those curved edges on it. Well, penguins will have serrated beaks to help grab and hold onto their food. But these little nubs inside their throat, these are called papillae. It's like having finger-like projections that help the food not go back out. Remember, they're going to eat a lot of food. So if they're trying to keep that food from swimming back out of their mouth, all these little finger-like projections, the papillae, inside their mouth will help keep the food down. So that does kind of look like teeth, you're right, but they don't really have the same function as teeth. Good question, Madison. All right, Lily's asking, can penguins be allergic to anything? You know, I am not sure. In terms of science, I think it's possible. And an allergy is when something's body is overreacting to some kind of stimulus. So let's say, like I was having this problem the other day. I was sneezing a lot. That's not just for fun. It's not really fun in my opinion. But something was in my nose. Pollen was getting in my nose, and my body was reacting to it. Now, I wasn't really having a strong allergy, but my nose was running a little bit. I was sneezing a little bit more. My body's reacting to it. It doesn't want it in there. Well, extreme senses of allergies are things that where your body's way, way, way overreacting to what's going on. So that can happen for a lot of people. But in other parts of the animal world, it doesn't happen as often. It can happen, but not as often because it's usually a negative adaptation for them. So if they were allergic to herring, and if that was their main food source, they probably wouldn't be able to survive very long. But because we have the capacity to alter our living space, our living arrangements, our food and diet, we can survive with certain kinds of allergies. Or with different kinds of medical care, we can survive with medical allergies. So birds probably can get one, but chances are, if it's a really extreme allergy, they probably wouldn't live too long, unfortunately. So that's just how nature works. Nature tries to have at least the most successful and the most averagely successful. So remember, it's not always the most successful that survive. You can be kind of average and do very well, but you tend to live longer and have more babies if you're at least an average adapted animal versus a poorly adapted animal. All right, Carson's asking, why can't penguins fly in the air? Well, look at those wings. Are those wings really long and feathery like we were looking at that tern? Here's some penguins, doing the woo. These are nice big wings, but not really very feathery for flying. Penguins are covered in feathers. Their whole body is covered in feathers except for their beak and their eyes and their feet. But the feathers on their wings are so small and overlapped that it kind of becomes like a boat paddle. Very powerful and very smooth, but not really good for flying. Other kinds of seabirds, shorebirds, backyard birds, they have long feathers on their wings. These are called flight feathers. So feathers on their body will be a little bit different than these big flight feathers. Have you ever found a feather walking around? They're kind of a different shape than what we might see on the penguin wing. These big flight feathers allow for the birds to glide and pick up speed and what we call thrust, so they can fly through the air and not fall straight out of the air. But the other thing about these birds is that a bird that can fly has bones that are less dense than a penguin's. So birds that are really good at flying have not hollow like a paper towel tube, but there's more airspace in their bones. A penguin has very dense bones because they need to be able to dive. They don't need to fly at all to do anything they do, but they do need to dive to get to their food. The birds that can dive the deepest, even birds that fly, have more dense bones. So a tern is probably not going to dive more than, maybe 20 feet in the water to get to their food. That's not that far. This bird, though, might be able to dive over 100 feet, maybe 150 feet down to catch their food. They need to be able to be dense and heavy to get down and swim without expending too much energy before they come back up, because they breathe air. They can't stay underwater like a fish. They have to come back up for air. The penguins can do this very well, too. Penguins have really dense bodies, so much so that even the emperor penguin, they're finding new depths that this animal can dive to. This animal can dive over 1,000 feet down. You're going to need a heavy body to just get down there without, like we use weights when we're scuba diving to help weigh ourselves down to get down where we need to be. A penguin just has that in their body. They're just heavier in the same size of bird compared to a bird that flies. So remember, density is how close things are together. So let's imagine we have, let's say like a can of peas. You're making soup. I don't know. I don't like pea soup, but we're going to use that example. Well, when the peas are all spread out, the density of peas is very low. We put them all into a can, it's very, very dense. So that is the same amount of peas, but in a smaller space, you've increased the density. So remember, water is really dense compared to air. Air, all the molecules are spread farther out. Water, they're really close together. So dense bones, more bone cells, more bone material in the same amount of space is a little bit more dense than those other birds that are doing things. All right, Nolan's question is, what is the difference from a human eye and a penguin eye? Ooh, that's a really cool question. I love this question only because I would love to have the same abilities this bird does in the water. Have you ever gone swimming? Pool, ocean, river, whatever. You try to open your eyes underwater. Not the most comfortable feeling. It's a little bit better in the ocean because the salinity or salt content of the ocean is very similar to our tears. Freshwater, very different. You know, my eyes don't feel good. You can do it for a few seconds. It's kind of painful, and you shouldn't do it for very long in freshwater. Well, our eyes aren't adapted to being underwater. They're adapted to having tears on them. That keeps our eyes healthy, but not really lots of water. Well, their eye, kind of the same, but they have a special adaptation. In order to see underwater, to capture their prey, they have an extra covering over their eye. Imagine you had two eyelids, not just one per eye, but two per eye. You have the ones that you can close your eyes with, but also a see-through one that protects your eye. It's like having an extra shield over your eyes. Or goggles. We wear goggles when we go swimming, or at least I do when I go snorkeling because it makes it really easy to see stuff. Imagine you had a natural protective layer over your eye so that when you're in the water, you can open your eyes. It's called a nictitating membrane, and a lot of aquatic animals have that. Alligators, a lot of reptiles, amphibians will have some of this, but especially seabirds, diving birds, or birds that go on a hunt in the water will have this nictitating membrane that covers over their eye. Now, in some cases, they might even see better underwater than in air. The cool thing is when you get to watch the penguins out at our exhibit, so when we reopen, you can check out the penguins, they'll watch you from above and below water. So they might see you a little bit differently because of that nictitating membrane helps them see underwater. They might prefer to watch you from underwater. That's really cool. All right, so we have a few minutes left. Let's see if we can get through all of our last-minute questions. Mrs. Nicolosi's class is asking, where do baby penguins hatch? Well, where do any baby birds hatch? Not in the palm of your hand, but on a nest. That's right. So that was a picture of one of the penguins that we had here. But that's what they look like when they're not brand new, because when they're brand new, they're like the size of a peanut. And then they start to grow up. They actually grow up very quickly. They get their first set of downy feathers. They're a little fluff. And that's what they look like. So when they're born, they're actually hatched, they're very small. But then they start to grow very fast. In most animal worlds, the babies will leave the parents pretty quickly. Depends on the kind of animal, but for the most part, especially birds, that baby bird is going to leave the nest very quickly. So they have to grow very fast. All right, Shayla's asking, how far can penguins swim? A lot. I think the migratory range of the Magellanic penguin is almost 3,000 to 4,000 miles. So if you were looking at South America, this is the entire range, or almost this entire side is the range of the Magellanic penguin. So they might breed in one area and then migrate and hunt up in another area. And so this is thousands of miles. They will go across the entire western side of South America. That's a huge range. Other birds, like the Antarctic birds, they'll swim out hundreds of miles from the continent so that they can go and find food. So, Shayla, hundreds to thousands of miles. Depends on the penguin. Sarah's asking, how far or how deep can a penguin and puffin dive? This depends on the species, but often at least 100 feet for penguins because their food's down there. Puffins are kind of maxing, or their most, the deepest they're going is about 150, maybe 200 feet. It just kind of depends on the puffin. So hundreds of feet to like the emperor penguin, up to 1,000 feet or more. We actually are learning more about how far down they can go. Sebastian's asking, how do penguins breathe while underwater? Ooh. So remember, they are birds. Now, birds and mammals breathe air. So where are they getting that air from? It's not the bubbles coming out of them. They hold their breath. So they have adapted the ability to hold their breath for some cases only a few minutes to maybe 30, 40 minutes or more, I think, depending on the emperor penguin being able to dive 1,000 feet. But the emperor penguins do get down 1,000 feet and back up 1,000 feet pretty quickly. So they are holding their breath for that extended period of time while they're underwater. Chloe asked, can birds get diseases or get sick? Yes, they can. In fact, our penguins here will sometimes get a foot problem called bumblefoot. Even in penguin world, what they get sick with has a cute name. Bumblefoot is when they get big sores or kind of welts on their feet because they like to be in the water, and on a rocky surface, if they're on a rocky surface for too long, they can get these sores on their feet. So at night, we actually put pads on Penguin Beach in our exhibit so that it's softer material, that they don't get this bumblefoot on their feet very often. But they can also get other things like malaria, they can get respiratory diseases, they can get sick just like lots of other animals can. But thankfully, we have a hospital on site that can take care of them if something happens. Eric's asking, how long can penguins live? The Magellanica penguin, I believe, can live over 30 years. And that's mostly under human care. Out in the ocean, maybe late teens to early 20s. But under human care, penguins can live a lot longer. Lots of food, medical care, no predators, and all the time that they can swim that they want to. So they can live a lot longer because of the care we can provide for them. Now, Jimmy gets the last question. Jimmy's asking, how do penguins hunt? That's a good one. So how would you hunt food if you're underwater already? So if you were flying around, you see a fish, you dive down and get it, like the egret or like the heron. But if you're swimming around, how do you find it? Well, they can't smell. Remember, they're holding their breath because they don't want to smell, because then they're going to snort water, and that's bad for you if you breathe air. So what senses would they be using? Sound and sight. Penguins can actually see light reflections very easily. So the shiny scales on a fish's body, they can see those light shimmers really, really easily. And they're really nicely attracted to that. So some of the enrichment or toys or games we get them to play with have these light shimmering effects to help provide that effect for them. So that's how they hunt, by sound, because sound is very strong underwater, and by their power of sight. Remember, they have that special eyeball with a nictitating membrane to see while they're underwater. Well, thanks everyone for hanging out. Teachers, if you're watching with your students so that we can better help serve that community, text us the number of students that you have watching with you so that we can keep an eye on how many people are really hanging out with us and learning from us in the mornings. Sarah's going to record those for us, and then we'll be back on Wednesday with more programming in our Aquarium Online Academy. Thanks, everybody, and enjoy the rest of your Monday.